Hi, welcome to our math. Today I'm doing a series of videos on rational functions. These are expressions. It says determine if the following are rational. If they are, find the domain. Okay, so a rational is a fraction. That's what rational means. And in this case, a rational expression means you have a polynomial divided by a polynomial. We can have x's in the numerator as well as the denominator. We cannot have the square root. So in base quick checking things out, we have a yes here, we have a yes here, we have a yes here. This is a big no, and the others are yeses. Yeses are more interesting. Okay, then it says find the domain. Well, the domain is the restrictions on the input, the x values. And in a fraction, the domain says that whatever in the denominator cannot equal 0 because you cannot divide by 0. If I can do this in a couple of ways. One way is to factor, one way is to isolate. X squared cannot be 25, square root with a plus or minus, which means x cannot be negative 5 or 5. Now, to me, this is how I usually write the domain. Sometimes people want a full sentence. All real values of x except 5 and negative 5. That also works. They mean the same thing. So you can do the domain as a sentence or as just your basic inequality. For this next one, we have a rational expression again. We don't care if there's a 0 in the numerator, just like we didn't here. You can divide into 0. 0 divided by 5 is 0. It's when the 0 is in the denominator that we have an issue. So this denominator can't be 0, which means x cannot equal 4 or negative 1/6. If you're not certain how I got that, I just set each of these equal to 0. For this one, I added the 4 over. This one, I subtracted 1, then divided by 6. Again, if you want to write this as a sentence, I could write all real values of x except 4 and negative 6. For this one, much like A, where I had the option of factoring first, this one I have to factor first. So two numbers that multiply to 66 and add up to negative 5 looks like x minus 11 and x plus 6. This cannot be 0, which means my domain is x cannot be 11 or negative 6. All right, this one, I can kind of explain what I did over here. Cannot equal 0. If I add the 9 over, 5x cannot equal 9, and then I divide by 5. But it doesn't matter because this one is a no, so I don't need to do this. The reason I'm not doing this is the domain is x cannot equal 9/5, but we also have a restriction here where x plus 3 has to be greater than or equal to 0, and so there's a two-step. And it's a little bit more complicated figuring out the domain, which is a perfectly acceptable process, but outside the scope of this video. For this next one, if I have 4x squared plus 9 cannot equal 0, well, that means 4x squared cannot equal a negative 9, but a positive times a positive is never a negative, which means this is all real. We're all real. Values of x. Or if you really want double bar r. What's happening is if we just look at this denominator as a graph, it's a parabola that never reaches the x-axis. And when we're solving, that's really what we're doing, is we're trying to find where x crosses, where this graph crosses the x-axis. What values of x would make y equal to 0 if this was equal to y? All right, for our last one, again, it's a yes. This one I get a lot of issues with students. They always want to give one of these answers because there's only an x, but that means the domain is x cannot be 0. If there's a variable in the denominator, then there's a restriction. If there's a variable, there's a restriction. Now, right here, there isn't a restriction, but we checked for the restriction. So I guess I should say, if there's a variable in the denominator, check for a restriction. All right. I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!